Hi Hussein. Okay, so today I would like to discuss the topic from the textbook, the position, that means exercise, or the section uh, 2.5. So section 2.5. Okay, so this is purely based on the concept of sketching graph y is equal to modulus of f of x. Okay, so sketching modulus of f of x and sketching modulus of f of modulus of x. Okay, so there is a significant difference between these two types of sketching. Okay, so you should understand clearly the concept of this kind of sketchings. Okay, so we'll start with discussing sketching of y is equal to modulus of f of x. So how to draw or how to sketch the graph y is equal to modulus of f of x. So we'll start with um, considering a function, say f of x. Okay, so f of x is equal to y. Then I will use that graph to explain y is equal to how to sketch y is equal to modulus of f of x. Is it fine? Okay. So how to solve or how to draw? So I will initially I'm considering one graph for y is equal to f of x. Say for example, I have a graph for f of x. It looks something like this. I'm now considering a cubical curve, somewhat like this. Okay, and it is passing through points minus to 0 and minus 1 0. Um, this is passing through 0 minus 6, and this point is 3 0. Okay, so this is the graph for y is equal to f of x. Y is equal to f of x. Now I would like to draw the same graph, or I would like to represent the same graph. Okay, uh, for y is equal to modulus of f of x. Okay, y is equal to modulus of f of x. What will be the strategy? So that means that modulus of f of x means even if whatever be the value of x, modulus means that answer will be always positive. So that means no value of y is permitted to go less than 0. So that means the same graph we have to reflect to the positive side. Okay, so negative y aspect of this graph we need to reflect that into the positive y part. So that means that I will represent with the blue color the negative region. Okay, so this region represents the negative part, and even this also represents the negative part. So we need to reflect these two negative part to the positive side of y. So then how it looks like? How it looks like? How it looks like? This is reflecting, and if I'm reflecting this, what happens? This will be definitely passing through 0 6 0 6. Okay, and again this part is reflecting, so this part is something like this, and if I'm reflecting, this looks like this. So this represents the graph of y is equal to modulus of f of x. So this represents the graph of y is equal to modulus of f of x. Did you get my point? Did you get my point? So this is how. So that means whatever be the value of y. So if this is negative, if we are getting a y coordinate, if so, identify the region where. So here the region I identified and that I marked with the blue color. So blue color we reflect it, and the reflected shape. Okay, so this reflected shape I have drawn. Okay, with the yellow color, and then anyway white function is already positive, so no need of no harm. So don't touch that white portion, right? So this represents. So that means the yellow region and white region togetherly called the y is equal to modulus of f of x. Did you get my point? Yeah. So that is about y is equal to f modulus of f of x. Now come to the second case, second scenario. So that is y is equal to f of negative x. I mean f of modulus of x. So that means that uh, forget about y part, because y can take any negative value or positive value, but all input values of x, all input values of x must be, all input values of x must be what? Positive. Input values of x must be positive. So whatever be the value, so that means that we will consider with a one example. Okay, then you will get a clear idea about this part. Okay, so how we can explain the concept, how we can explain this concept? To consider one graph, say y is equal to f of x for x greater than or equal to 0. Okay, x greater than or equal to 0. So that means that somewhat like this. So that means it passes through 0 1, and this point, let it be 1.20, and this point is 30. Okay, so this is a graph for y is equal to f of x, where x greater than or equal to 0. So if you want to draw the graph for y is equal to f of modulus of x, the idea is you should reflect y is equal to f of x. You should reflect y is equal to f of x on y-axis. So that means I will reflect this. So if I'm reflecting this part, definitely you are getting a shape something like this. Okay, so that means this coordinate is minus 1.22. Okay, and what about this coordinate? This coordinate is minus 30. Okay, and this is the graph for y is equal to f of modulus of x. So that is the main difference. Okay, so if we want to find y is equal to modulus of f of x, reflect y is equal to f of x on x-axis. On x-axis. No value of y is negative. Okay, no value of y is negative. So that is a speciality of this concept. Anyway, we will do some example. Okay, so we'll start solving by considering one example. So question example 1. Question is f of x is equal to x square minus 3x minus 10. So automatically the question is sketch the graph of y is equal to f of x. Then second question is sketch the graph of y is equal to modulus of f of x. And the third question, sketch the graph of y is equal to f of modulus of x. So these are the three questions. Sketch the graph of y is equal to f of x. Sketch the graph of y is equal to modulus of f of x. Sketch the graph of y is equal to f of modulus of x. So these are the three questions. Now we will start sketching. Okay, the sketching part is okay, right? The sketching part is okay. So we'll start answering a part. So what is our f of x? F of x is equal to x square minus 3x minus 10. Okay, so anyway, the coefficient of x square is positive. The shape must be a upward parabola. And we need to check whether the graph crossing x-axis or not. How we can factorize this? So is it possible to factorize f? Of course, the product sum rule, right? So 1 into minus 10, we have to get minus 10. And we have to get a sum of minus 3. It's good for splitting the central term. So minus 5 multiplied by 2, we are getting minus 10. Minus 5 plus 2, we are getting minus 3. So x square minus 5x plus 2x minus 10. So that means if I'm taking x from the first two terms as common, and then I'm taking 2 from the next two terms as common. So it beautifully factorized into x plus 2 times x minus 5. Am I correct? Now, if this is intersecting at the x-axis, we can equate y coordinate to 0. So that means 0 is equal to x plus 2 into x minus 5. So either x plus 2 is equal to 0 or x minus 5 equal to 0. So that means x is equal to minus 2 or x is equal to 5. So the graph must be somewhat like this, right? So it is intersecting at a minus 2, 0, and it is intersecting at a 5, 0. And the shape must be in upward parabola. Then we need to find this coordinate. Which coordinate? The y-intercept part. So how to get this y-intercept part? So what is our f of x? X square minus 3x minus 10. So you substitute instead of x. substitute 0, because on y-axis x coordinate is 0, right? So 0 square minus 3 into 0 minus 10. So that means y coordinate is equal to minus 10. So that means when x is equal to 0, the corresponding y coordinate is minus 10. So now we got the equation for, draw graph for f of x. So this is the answer for part A. Part A answer. Now, part B question. Part B question. So what is part B question? Y is equal to f of y is equal to, we need to do y is equal to modulus of f of x. So what is the rule? What is our rule? Reflect all negative part of y into positive y-axis along x-axis. So that means minus 0 minus 10 becomes 0, 10. So then the blue region in the positive aspect from the yellow region plus blue region in the positive aspect represents the answer for what? The second part. So the graph must be somewhat like this. It is coming to minus 2, 0, and this is 5, 0. The graph is coming to, minus 2, right? Then what happens? Autumn flex. So this is the answer. So this is 0, 10. So this is the graph for y is equal to modulus of f of x. Okay, and then C part. So we need to draw the graph for y is equal to f of modulus of x. So how to approach this graph? How to approach this graph? So y is equal to modulus of f of x means that y is equal to modulus of f of x means, so what is y is equal to f of x? X square minus 3x minus 10, right? Then y is equal to modulus of f of x means, not modulus, y is equal to f of modulus of x. So that means every value of x is replaced with the modulus of x square minus 3 into modulus of x minus 10, right? So that means whatever be the value of x, because x can take both values. What values? Negative as well as positive. But the y value must be always positive, right? Y value must be always not positive. Y value must be always same. Okay. Whatever be the value of x, even if for x is equal to minus 2, or even if for x is equal to 2, the y value remains same. So that is the meaning, right? So what is our graph for fy is equal to f of x? The upward parabola. Then what happens to the graph? What happens to the graph? I will draw the graph. Okay, I will draw the graph for f of x once again. I will draw the graph for f of x once again. So this is y is equal to f of x graph, correct? Y is equal to f of x graph. That means this coordinate is minus 2, 0. This coordinate is 0, minus 10. And this coordinate is 5, 0. So this is the graph for y is equal to f of x. Now, the scenario for, or how to draw the graph for y is equal to modulus of f of x. So the idea is what? reflect the part of the curve y greater than or equal to 0, not y, I mean x greater than or equal to 0. That means the positive values of x in the y-axis. How? How? So this positive aspect is what? The positive. So we need only positive aspect. We need only positive aspect. We need only positive aspect. So I will draw the positive aspect of f of x. Then I will reflect it. Okay. So this is the positive aspect. This is the positive aspect of the graph. Positive aspect of the graph. Okay, positive aspect of the graph. Then you reflect the positive aspect of the graph. Okay, so I will use a different color. Because then phi 0 means obviously it becomes minus phi 0. Positive aspect, and then the shape is the exact reflection of y greater than, I mean x greater than or equal to 0 part. Y is equal to f of x. I need to consider only the positive aspect of x. Then you reflect that on y-axis. So this represents the graph for y is equal to f of modulus of x. Got it? So that is how we are doing this question. Now we move to another set of example. Okay, so in this question, example 2. So in this question, they provided you a graph. The diagram shows the graph of y is equal to h of x with the 5 points labeled. Sketch each of the following graph. Sketch each of the following graphs, labeling the points corresponding to A, B, C, D, and E. And any points of intersection with the coordinate axis. So question number 1 is y is equal to modulus of h of x. Question number 2, y is equal to h of modulus of x. H of modulus of x. Okay, so the instructions are very clear. They provided you 5 parts or 5 points or 5 coordinates are marked in the respective diagram or respective graph, and underline the key points or instructions. Sketch each of the following graph. So we need to sketch each graph, and we need to label A, B, C, D, and E. And apart from that, and any points of intersection with the coordinate axis we have to mark. Okay, so these are the main points or main objectives we will accomplish after doing this question. Clear? Okay, so I will provide you the graph, and this is the graph for h of x. This is a graph for h of x. This is x-axis, and this is y-axis. And now, naturally, the question arises. Is what are the coordinate axes? I mean, coordinate points. Or where is our graph? So I'm giving graph. So this is A, and the graph is somewhat coming like this, and it is going somewhat like this, and it is basically a cubical curve. It may or may not be a cubical curve because it forms a asymptote. So I'm not sure whether it is a cubical curve or not, but yeah, some points are given here. So A coordinate is given -7c, and this point is B. This is -2.5 and 1.5. -2.5. I mean, this is 50. It's not 1.5. This is 50. Okay. Now, this point is C. This point is C, and this point is 0, 11. And this point is D, that is 3, 0. And this is E, 6, -1. Okay, so this is a graph for y is equal to h of x. So I'll give you some time. You just go through this question and try to draw or try to attempt the part A and part B. Then I will solve this question. Okay, so you just go through these following notes, right? So what we will accomplish after this question, definitely we need to mark all these 4 or 5 points, and apart from that we need to mark the coordinates the graph is intersecting with the respective y and x axis. So you just go through this note and you try to understand what scenario we will do and what we will do for drawing a graph for y is equal to modulus of f of x, and what we will do to draw the graph for y is equal to f of mod of x, right? So I'll give you some time. We just go through this, then we will accordingly do this question. Okay, so come to our question. I hope you figured out how to do this question. this question. Anyway, you can cross verify the solution part of this, okay, because it's slightly confusing, like, coordinates, right? So accordingly, we need to write coordinates for each case. So how we can write coordinates, how we can draw? So first you can take the concept of first you take y is equal to modulus of h of x, modulus of h of x. So in this case, we need to reflect all negative h of x part to positive y. So it will, how we can reflect it? We can reflect like this. Right? So that means y is equal to h of x. Graph looks like this. Then corresponding coordinates. What about the corresponding coordinates? In this case, A exactly remains same, -7, 0. And what about B part? That also same, -2.5, 15. And what about this? This is 0, 12, right? 0, I mean, this is 0, 11. 0, 11. And what about this? This is 3, 0. What about E? E becomes 6, 5. Because for the value of E, for the value of x is equal to 6, we are getting -5. But if after reflection, it becomes +5. Yeah. So that is the answer for this part. I hope you understand this case, right? So this is how we are drawing the graph for y is equal to modulus of h of x. Now, move to part B. We need to draw the graph for y is equal to h of modulus of x. H of modulus of x. So how we will draw this graph? The idea is we are only interested to take the positive aspect of h of x. So I will draw the positive aspect of h of x first. So if I'm drawing the positive aspect of h of x, the positive aspect of h of x. So this is a positive aspect of h of x, right? So this was our c coordinate. And we know that this is 0, 11. And we know this point is 3, 0. And this was our D, right? And this is E. And this coordinate is 6, -4. So for drawing the graph for y is equal to h of modulus of x, the strategy is we need to reflect the positive aspect of the positive x aspect of h of x along y axis. Then after reflection, what happens? This is our respective coordinate. This is our respective coordinate. And after reflection, the graph looks like this. So that means the entire The negative part got eliminated and D becomes D dash and E becomes E dash. Am I correct? E becomes E dash. So you might be, so this we can, in the previous question, we can say that after reflection, it becomes E1, right? Okay, or E dash. So what is the coordinate of E dash and D dash in this case? So D dash will be minus 3, 0. What about E dash? It is minus 6, minus 4. Minus 6, minus 4. So this is how we are drawing the graph of h of modulus of x. So this is the idea. So as a note, we can say that reflect x greater than or equal to 0 part of h of x along y-axis. So that is the answer. Okay, and that's all for the day. Thank you.